director do not need an introduction. A very good evening, everyone, and welcome to another session of Precision Agriculture. It is my pleasure to introduce our chief guest, Dr. Ranjan Bhatt, who has graciously accepted our invite to join us today. A brief introduction to Dr. Ranjan Bhatt is, Dr. Ranjan Bhatt is working as Associate Professor in the discipline of Soil Science in Krishi Vigyan Kendra, Amritsar, Punjab, India. And he is associated with Punjab Agriculture University, Ludhiana from 24 January 2006. He did his PhD in the discipline of Soil Science as an in-service candidate in the year 2015, where he delineated the soil moisture dynamics, land and water productivities of rye to wheat cropping system as a whole, including the intervening period for the first time in the region. He already handled 5 research projects pertaining to polycoated urea, basmati rice productivity, potash role in sugarcane under deficient soil, polyhalides, and potash salts of active phosphorus as a PI to 2 projects and co-PI. Up till now, Dr. Bhatt honored with 18 awards at national and international level and has reviewed 70 research articles after receiving invitations from high-impact journals. He also holds the offices of 12 professional national-level societies and also acts as editorial board member of 5 journals. He authored more than 120 scientific research papers, 4 research bulletins, 10 books, 40 book chapters, and 86 extension articles from the Benefit and Agriculture Society farming community. Dr. Bhatt acquired BSc Agriculture from Guru Nanak Dev University, Amritsar, Punjab in India in 2000, while MSc and PhD as an in-service candidate in the discipline of Soil Science and Agriculture Chemistry from Punjab Agriculture University, Ludhiana, Punjab in the year January 2003 and July 2015, respectively. So we are delighted to welcome you in another session of Precision Agriculture, and we would like to request you to enlighten us with your knowledge.
I'm quite thankful to the organizers for providing me this chance. I am quite delighted to share my views on the resource conservation technologies for the precision agriculture. May I audible? I'm audible.
Yes, sir. You are audible. Yes, sir. You are
audible. But your presentation is not visible, sir.
Okay, just I'm going to share my screen. So, all the respected present, here I am going to present the resource conservation technologies for the precision agriculture. The precision agriculture is really a new concept, even for ourselves also. And most of them are quite familiar with the resource conservation technologies and the climate smart technologies. And as there is a lot of you.
Please एक बार देखिए अपने लेवल पे PPT visible नहीं है.
PPT visible नहीं है sir?
नहीं sir.
Sir, I have shared it.
रोहित जी आपको visible है देखिए.
No sir, PPT नहीं show रहा है.
आप PPT show नहीं हो रहा.
PPT नहीं show रहा sir, खाली screen show रहा है.
Okay, sir मैंने वहां से share किया है नीचे से. अब देखिए, अब ठीक है?
हाँ अब ठीक है सर, बिल्कुल.
Okay, thanks sir. अदर नहीं तो कई बार काफी निकल जाती है स्लाइड्स, तो बाद में पता लगता है कि विजिबल ही नहीं था. Okay, so as there is a lot of hue and cry regarding the escalating population, and we have to produce a much amount of the food, a quality food for them in terms of reducing labor and carbon and water energy footprints, with the aim to produce a quality ground. So by increasing their use efficiency of the different inputs like water we applied, fertilizer we applied, and pesticide or fertilizers. So we all need to improve. All the technologies are there to improve the use efficiency and to reduce their footprints. The main aim is to decrease the cost of cultivation, improve the livelihood of the farmer. So in that regard, I have tried to compile this presentation. So precision agriculture, as for journal, as we is a relatively new method, as I earlier told, is a new method of farming that makes use of the wireless sensor networks and things of internet and cloud computing, artificial intelligence, machine learning, and two main aim is to maximum the crop yield. So in the artificial intelligence, we have drones with us, and things of internet, we have the different machines with us, like laser levelers are there, SPAD is there, green seeker is there, and new machines are there with us to how that we can apply the need-based fertilization, particularly to improve the yields of the crop. And the majority of these studies conducted so far support the idea that the PA-based practice significantly affect both long-term viability and the production goals. The purpose of the PA is to offer the decision making, particularly for the farmer policymakers, based on their own situations. As we all know, the soil texture, soil properties are varied from field to field. So it's a site specific. It may possible that one technology is applicable in one field, but it may not possible that that particular technology is applicable to the neighbor farmer, even to the neighborhood farmer. So there is a need for the more precision. So we have to develop a more precision. So as far as goal is concerned, our main goal of the precision agriculture is finally to reduce the cost of cultivation of the farmer, improve the yields, improve the use efficiency of the different inputs. As was like, there is efforts to reduce agriculture negative effect on the environment. As I already told, it's greenhouse gas emissions. More the fertilizer applied, more the emissions are there, and more the adverse effect on our agriculture and human health also. And that is assistant to small scale farmer. Basically, small scale farmer the main sufferer to any adverse conditions. Then increase in crop yield, of me, and then protecting plant and animal life, encouraging people to use the natural sources like soil and water, but in a sustainable manner. But in our Punjab, as I want to convey over here, that in Punjab, the electricity is free for drying up or withdrawing the water, and the farmer free mean the farmer is not taking care of our calls to use it judiciously. The submersible pumps are there, and the water ground is quite going down, and the rice is blamed as the main culprit. So main technologies, resource technology, precision agriculture are mainly focused on the particularly on the rice, because our region is not fit for growing the rice. It is the call of that time that we have, you can say, forced to go for rice cultivation. Basically, rice is not our crop in our region in Punjab. We are going for the grams, legumes, and wheat is there, maize is there, but rice is, you can say, there is a need to go it. Then a goal is encouraging the people to use, as I said. In addition, PA enables a smart farm management by allowing the farmer to gain insight from their vegetative indices, that how the crop is growing, what type of the weather is there. So one from the remote sensing, they can easily analyze the up to when they go the rain. So there is no need for the irrigation, and what is the field history data. So all things we have to take in mind. Now, as I just conveyed, that rice is not our crop. Punjab surface is not leveled. It is from southwestern to northeast to southwest, declining from northeast to southwest. And in the southwest districts, there is a problem of water lagging at one time. Water lagging. There is a problem, another problem of, you can say, salinity problem or the sodicity problems. No crop is able to grow over there. So we are forced to grow rice, particularly on that region only, like Mansa, Bathinda, Faridkot, where the underground water qualities are not good. But as a minimum support prices offered to the farmers for the rice and wheat, the farmers are more attracted to, because they got the insured. So the rice areas increased from 0.3 million hectare to 2.61. Now it further increased. And you can easily see here the area under the pulse is reduced because there is no MSP for the, MSP is there, but very less farmer is able to get it. And then you can see wheat area is also escalating while the maize area is reduced. So the main rice wheat cropping system in our region predominates over all the crops, with the effect soil health is deteriorating, underground water level is going down day by day, season by season. So there is a condition to go or for advance to recommend the farmer the proven technologies so that they can fulfill their living requirements by judicious, sustainable, climate smart use of the natural resources. Yeah. So as I already told, the rice in our region is the main assumed as a main culprit for the decline in the water level. So all the technologies are mainly focused on the rice. Now the reason identified here are, first is the conventional way of growing the rice and wheat. In the puddled system, the farmer, what they have done, they sent the water and they puddled it. So when the farmer puddled the soil, as a scientist, we know that the soil comprised of sand, silt, and clay. And when the farmer puddled the soil, this aggregate break up. And there is a Stokes law, which states that the rate of fall of any particle is directly proportional to its radius. All of us very well know that sand is having higher radius. So settle first, then silt, and then clay. Clay will form a hard pan. This is the reason with the puddling, the sand dune we have, the farmer level that sand dune, go for the puddling, create a hard pan known as flow pan, and they grow the rice. But what will happen after rice? We need to grow wheat, that is aerated crop. So there is a lot of difficulties. Farmers feel that the wheat roots are not able to get properly aerated. The leaves of the wheat crop become pale yellow. The farmer again apply the ignorantly urea, but that is only because of the formation of the hard pan. So every field which is plowed with the rice from 8-10 years, we mostly go to the farmer fields and it is plow pan is formed. So there is a need to break that one. And most probably that around our scientists calculate around 4,000 liters of the water required to produce only 1 kg. To produce only 1 kg of the rice, and 1 liter of bisleri bottle cost about 25. So we can multiply and judge that how costly 1 kg of rice cost to us. So secondly, 85% of area is under rice. So rice faces higher evaporation because the hot summer seasons are there. Adaptation of the long duration varieties in the region, farmers are mostly using Pusa 44, not recommended by us. We are recommended the medium and short duration varieties, but Pusa 44 stays in the field seed to seed about 160 days, and it take up a number of irrigation, like you can say about 30 irrigation. Pusa 44, no doubt yield potential is higher, but it is not suitable for us. But even then, after cutting, the farmers are not convinced. They mostly around 40 to 50%, more than 50% area of the state is still under Pusa 44. Then early transplantation of the rice is responsible for the declining water table. Now why? Because if farmer go for the transplanting in the May, the weather is dry, and the dry weather demands for the evaporation is more. The dry weather, hot weather, we have to provide number of irrigations, higher number of irrigation. While if we go for transplantation of the rice after June, the rains are there, dry air become humid, and humid air is not able to uplift the water vapors, and the number of irrigation, the interval between the two irrigation increased, and the total number of water decreased, and the water productivity will increase. And then inefficient water supply in the rice, free electricity for the private tubers, particularly for the state. Unleveled fields are there. In the field, some rice plants are not able to grow because of their higher, and some are due to the lower levels. And the deep submersible pumps are there. Earlier, in 1960s, we have centrifugal pumps, and the motor of centrifugal pumps is on the table. higher slope. As the area of rise increased, that motor become on the surface of the soil, and as the more area of rise increased, that motor goes into the tube well. And now the condition is that the centrifugal pumps got failed. Now we have to depend on the you can say submersible pumps now installed in the state, and there is a lot of problems are there. No doubt we have electricity, but more electricity is required to pump up greater amount of the area, and then reduced area under fruit, vegetables, other leguminous crops. As we all know, the leguminous crop is responsible for making the soils healthy. But as the area under rice, other crops increase, the area under fruit, vegetable, and leguminous crop is reduced. In 1960, as per different estimates, to date, we required around about 43 lakh hectare meter of water. And what we have in our pocket, we have 30 lakh hectare meter of the water, around which 14 lakh hectare meters comes from the rivers, from the dams, and the 15.5 lakh hectare meter of the water comes from the rainfalls. Even then, we are lack of 13 lakh hectare meter of water every year if we want to produce all the crops with the full grain potentials. So that we need to, we need to withdraw from the underground water level. Time trends of the water demand, as we can see that from 1970 to 1980, 90 and 2000, 2008, that water demand is escalating from 1970 to 98, 32%, then 55%, 68%, 72%, and now it also escalating more and more. Yeah, this is the how the water table is declining in the ground. In 1973, around the rate of fall of the groundwater is just 0.2 meter per year. But with the grown of the particularly rise and the conventional methods of the flooding, it hiked up to 1 meter per year. So the water, as per groundwater cell of the government of the Punjab, the water level is going down, 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 and down. So a number of measures have been taken care, and we are trying to balance it up. So this is the condition in water level. As I know, this district of Punjab, the water is going down, water level is going down. In other sides, southwestern district, as I earlier said, the south is downside of the Punjab is southwestern district like Mansa, Faridkot, those regions. And there the problem waterlogging is there. So once the problem waterlogging is there, salt water come up, water evaporate, and salts remain over there. So the problem of color soil, you can say, is there. So at that time, there is our need to go for rice, because rice is a crop that can sustain in these conditions. Irrigation trends by the canal and underground. So we all know that for irrigation, we depend mainly on the canal and underground water. But in the state, we can see that around in 1950, 29% is requirement would fulfill from the underground water. But as the time passes, in 2005 and 6, it grows up to 60% round about. So we're depending more about on the underground water levels. And it is mainly true for the northeast states of the Punjab, and particularly in the north southwestern, still the farmers are using the canals, because in the canals we are applying the better quality of the water as compared to their underground water table. Yeah. Now this is the how water. India is the largest groundwater user in the world, as per one of the article Current Science has appeared. So it shows that in 1990, particularly the agriculture demand is highest. But see, the industrial demand is escalating from 33% to 110%. So it's so we have to provide the electricity to the industry sector also. So there is a cut to the agriculture sector. But we are, as we are growing the rice in the conventional way, we need to apply more water. So there is a conflict between the industrial and the agriculture sector. No doubt the demand of the household is also increasing, because number of houses are increasing, urbanization is increasing, the way of living is urbanization. So we need more water. So that's why we can see that there is more struggle is going to come in 2025 in between the industrial sector, household sector, and the agriculture sector. So we need to educate the farmer regarding the recommended practices, particularly for the precision agriculture technologies, so that the farmer can use the resources in a sustainable way, so that we can offer the water to the other sector also. Yes. So transplanting, yeah, this is the normal practice which we mostly have done in our region, transplanting. But during the corona region, last couple of years, we have observed the corona. So in that region, these operations quite suffered. But and we are depending on the direct seeding of rice. That is another a big story, because farmers are forced to go for direct seeding of rice because the migrant labor are not visiting our state. So, but DSR, direct seeding of rice, is a site-specific technology and it requires the medium to heavy texture soils. And in our region, I know many farmers during the corona time, they go for the DSR in the light texture soil. And due to the heavy wheat population and the iron deficiency, the crop totally failed and they have to till up their paddy crop, then again going for the puddling and then going for the basmati. So transplanting, manually transplanting is time consuming, energy consuming, water consuming, no doubt, practice. And there is a number of disadvantages of the puddling. Underground water level is going down and the soil structure is deteriorating, soil health is deteriorating. There is adverse effect reported on the soil physical properties, chemical properties, and as well as biological properties too. Now, the precision agriculture, what are the different techniques which precision agriculture, we can go for the precision agriculture, we can educate our farmer to adopt those technologies. No doubt these technologies are new to the farmers and they are quite hesitating to adopting them. But if we conduct the on-farm trials, demonstration at the field, so if we conduct the demonstration at the field regarding the laser level, DSR, drones are there, remote sensing there, and the green seekers pad and the leaf color charts is there. In Punjab, we are distributing thousands of leaf color chart free of cost after depicting the different demonstration, and it definitely have an impact on the different nitrogen fertilizers demands. Now, this is the precision laser leveling. A number of technologies is being offered, but this is the technology which grows and familiar in between the farmers, and farmers adopt it by themselves. No doubt the technology is costly, but through the cooperative system in Punjab, we have very well cooperative systems, and through the cooperative systems, cooperative societies, farmer can easily got it. Basically, there is a tripod which we have to install outside the field, and then we have to make a survey. On the basis of the survey, we have to set up the this hydraulic system, and where there is a need to fill up the soil, the system will laser level fill up the soil, and where there is a need to uplift it, then the leveler will uplift. So as the table is leveled, after the laser leveling operation, the field is become leveled and area is also increased, and the time to irrigate the particularly time to irrigate a particular acre is reduced. So with the less of the electricity, we are able to irrigate more and more number of the farmer. Weeds are also controlled. So this is the very best technology which is being adopted, I think, all over the India due to its different benefits. Yields also increase. So here we can see that among the different resource conservation technologies or climate smart technologies like laser level, zero till, reduced till, surface shading, and all that, it is being reported the maximum area is under the laser leveling. And it is, yes, it is only because the maximum benefit is being provided by this technology. No doubt it is a costlier one, but with the help of the cooperatives, farmer can on the sharing basis can easily adopt it. Actually, after the wheat season, we have a window of around about 1 month, 1.5 months. So we can advocate the farmer to go for the laser leveling. We can advocate the different green manuring also. The farmer to go for the green manuring, particularly 60-day SML 668 and cowpea, dhancha, and rawa to the farmer to go for the green manuring. If they green manure these crops before the kharif season, there is no iron deficiency. Organic matters, the pillar of the soil quality is improved, and if it improved to more than 0.75, then the demand of the fertilizer, particularly urea fertilizer, is decreased. So this is the scenario that the laser leveling has highest area till date. Now, we have seen that the effect of the laser leveling, the yield and the water productivity is for if we compare with the rice and the wheat, then we can see that the laser leveling has higher in both in rice and wheat. But in the rice wheat cropping system, we have reported a jump of about 6% in the yield, whereas input water productivity is concerned, the water productivity both in the rice wheat system is 16.2% is reported higher in the laser level as compared to the traditionally leveled fields. But similarly, on the green yield and water productivity, the Paul has observed that if we go for traditional level with no fertilizer, then traditional leveling with recommended fertilizer, then the laser leveling. So we can report that the effect of the fertilizer is there on the water productivity because grain yield increase, it's 22.7%. But when we go for the laser leveling with the recommended dose of the N and P and K, then particularly due to the reduced water demand, the irrigation, the water productivity is increased 68.5%. Gell et al. In 2008 in sandy loam soil have also observed a saving of irrigation of about 18.4% and 12% improved in the yields, and the total water usage is reduced. Similarly, we have also observed in the unleveled field, then laser leveling once and then the laser twice. So as the number of laser leveling increased, the preciseness, the precision of the land leveling improved, and grain yield increased, water saving improved, and the water productivity also improved. This is a similar slide where we can see that the precision leveling is reported with a 47.5% higher in the irrigation water productivity. Now, under the different establishment method like direct seeded and the puddle transplanted rice, as far as rice yields is concerned, under the DSR, we have reported that traditional level as compared to traditional level, laser level resulted in 2.94% higher yields, whereas in the puddle transplanted rice, it reported with the more 9.24% higher grain yields. While in the water productivity is concerned, laser level have higher water productivity due to the lesser use of the water, due to the all hooks and dunes are being leveled. So 14.6% improvement in the water productivity in the DSR crop, while in the PTI crop, there is a improvement of the water productivity about 18.1%. So yes, laser leveling is a perfect solution for the declining water level, for improving the water productivity, and also to go for the climate smart agriculture, because water footprint particularly reduced over here. Now, coming on to the drones, a drone is a new technology. All of us are quite familiar. We will see in the Hollywood movies and other movies also that the drones are going. But for what is the role of the drone in the precision agriculture? How we can so as far as different parts of the concern, as an introduction, I have tried to compile this information. So this is the mode of operation of the drone. The drone can be used for applying the weedicide, herbicide, and also to assess the different parameters. And these are the different parts of the drone. We can say that the spray nozzle is there, carbon propeller is there, and pluggable tank is there, battery is there, charger. So drone is a perfect solution where human can't see. The drone can over there. So it provides a real-time based data. It also helps us to, like, for example, we have green seeker with us. And the green seeker, we have, you know, green seeker, we have to take the reading above the biomass. So suppose if we have sugarcane crop with us, which goes up to 6 foot, 6.5 feet, COPP 95, COPP 96, COPP 98. The current release variety is sugarcane varieties, the Punjab goes up to 6.5 feet and above that. So how scientists can monitor the reading on that? So the drone is a perfect answer to that. We can fix the green seeker or with the help, and drone can take the readings for us, and even for the fertilization purpose also. So as for the different uses of drone is concerned, it helps us to monitor the crop condition, crop health, and what is the land area. It also helps to manage the livestock. It also helps to irrigation system monitoring, spray the fertilizer and chemical. Though the trials are going on in our universities also, we are trying to come up with but there are many hurdles are there. So how we can make this technology familiar with the farmer, because this is a somewhat costly technology and the farmers are not familiar. Even sometimes when we have to go to the farmer, we have to convince them regarding their results. So these are some other benefits of the agricultural drone, that it helps in increasing the yield. It helps to reduce the cost of cultivation. It helps to judge the attack of insect and pests. So drone is quite effective. So common challenges which are associated with the drones are the farmers and the smallholders cannot use the drone without the permission. And the high-tech drones can be expensive. Second one, as I earlier explained, drones are costly, yes, and it's hard to fly without instruction. Cheap drones in India can only fly over a short area. For the larger distances in the crop area, more expensive and advanced drone may be needed. So remote area, sometimes I don't have very good internet connection, so we need to work on that. Then agriculture drones are not able to work in the harsh climate. So we have to take care of all these factors and then plan accordingly. If we call upon the recommendation, then the drone have a major impact on the agriculture. The farmer can boost their productivity, reduce their cost of cultivations, can judge the attack of insect pest or other elements in advance. So agriculture drones in India are affordable, but we have to work on it. We have to policymakers, and we have to. This is really a new technology even for us. It's quite sometimes difficult to get. Then the remote sensing. The remote sensing is also not a new technology. We all are well know. We know the remote sensing help us to sense the things from a remote distance, like the weather parameters are there, and we can judge the any rains are there, harsh climate is there, so that we can. But how to the farm it can help, because everyone, shopkeeper, businessman, can take care of the weather element, but not the farmer, because farm crops are in the field. So remote sensing, it helps us in managing the natural resources. So managing the agricultural practices like land use, land conservation, and soil carbon stocks, help in estimating the soil carbon stocks, help in estimating the different nutrients like the organic carbon. What is the organic carbon status? What is the phosphorus status in the region? Conducting the tactical forest firefighting operation. So different these are questions, and it helps us also in the making the better decision for a particular pocket suffering from a particular problem. In our district, Amritsar, this is the view from the space, and Punjab remote sensing is we are acknowledged the agency which helps us to provide us this graph. This is the view from the space, Amritsar. Now, status of the soil organic carbon. So this is we can see the status of the carbon as the from the graph. There is the less than 0.4 organic carbon is there. So we need to apply 25% higher urea, particularly in dot pockets, and then middle pockets have green one, and where blue are there, it means the farms are going for the green manuring or the farm germ manure, and there is organic matter is good. Similarly, phosphorus and then the potassium. So with these graphs, we can easily identify the pockets or identify the blocks where we need to work on. As far as organic carbon is concerned, particularly in organic carbon, where the yellow regions are there, we need to go over there and educate the farmer to go for the green manuring and to go for the farm germ manure, so as to improve its organic carbon, or you can say soil organic matter or stocks. And similarly in the potash, particularly potash is a question. Potash is a quite burning issue in our region, because most it is said that the elite mineral is supplying the potash. But we have now observed the potassium deficiency, particularly in our region in Punjab, in sugarcane. It's quite astonishing that in the wheat and rice, for the wheat and the rice in the deficient soil, the recommendation of the potash is there. But for the sugarcane, particularly for the sugarcane, there is no recommendation for the deficient soil. So my team conducted this experiment, different pockets of the Punjab, and we have estimated 80 kg of the K2O per hectare, or you can say 50 kg of the muriate potash found to be best for as far as different quality parameters should be concerned. Now the green seeker. Green seeker is also a new technology, and till date, it is in the hands of the scientists, and we are trying to go at the farmer field and demonstrate this technology. But again, this is somewhat costly technology. So this is a green seeker, and how it works. Yes, it works on the NDVI, and in the NDVI, this is the, I also mentioned the formula over here, that it is the difference between the reflected minus red and reflected plus red reflected. So if NDVI reading ranges generally from the 0 to 0.99, or higher the reading, the healthier the plant. Means the plant is more green, more good chlorophyll content. It means the best quality of the soils are there on which it is growing, and the 0 represents the no vegetation. So the green seeker is a non-destructive tool for calculating the crop nitrogen demand based on the crop soil composition and the plant health. The green seeker use light emitting diode and to generate the red light, that is 660 nanometer, and near infrared light 780 nanometer. So the formula I have already mentioned. Healthier plant absorb more red light and reflect more infrared light. So it helps to reduce the pollution. How? Because on the basis of the green seeker reading, we can decide that in which plot we need to apply how much of the fertilizer. So I definitely there is a reduction of the applied fertilizers, and definitely there is a reduction in the greenhouse gas emission. So also there is a nitrogen use efficiency also improved. So it has a strong potential to increase the farmer profit over there, as it reduces the cost of cultivation of the extra fertilizer which farmers are applying innocently. Now the way forward, the green seeker is really a cut-edge instrument for calculating nitrogen carbon, particularly in the rice we are using it, and we are also using the green seeker in the sugarcane and other crops also. And using NDVI data, growers may determine, farmer may determine how much of the nitrogen to a particular crop in a particular field they need to apply. So things are in our hand, how to precisely we use this. Then the leaf color chart. So leaf color chart, green seeker is a costly technology, as I already said, but the leaf color chart is equally better, equally same, providing effect if properly used as compared to that of the green seeker. And our scientists also publish also a number of research paper on it. So leaf color chart, this is a leaf color chart, PAU leaf color charts, and this leaf color chart we have already recommended in the region for the rice, maize, wheat, and the you can say cotton, for the properly use of the fertilizers. And this is a non-destructive technique. In this technique, firstly we need to apply the basal dose of the fertilizer, and then afterward we have to compare the color of the crop, color of the leaf with the strips of this. If the color of the after a weekly interval, if in any week out of 10 leaves, the 6 readings are above the provided strip, like in rice it is number 4. So then we no need to not to apply fertilizer. But however, if in a particular week the number of leaves readings are having less than 4, is more than 6, then we need to apply the fertilizer. So this is a handy instrument. We can easily go in the field and can take the 10 leaves, disease-free leaves, and then compare their reading, compare them with this leaf color chart. We have also distributed a number of leaf color chart, and in our Krishi Vigyan Kendra also we are providing this free of cost to the visiting farmers, and also conducting number of demonstrations, so that then ultimately it's 100 rupees instrument, not much costly. Even then we providing them free of cost. This is the different directions how to use it in a local language in Punjabi. So this is the sum of the results of the basmati crop. Here we can see that with the help of the leaf color chart, we can apply up only 33 kg of the urea per acre, where a farmer can apply up to 76. While you can easily see there is an almost similar yields are obtained. So saving of fertilizer there, cost of cultivation reduced, greenhouse emissions is reduced. So this is the perfect technology being propagated and recommended by the Punjab Agriculture Ludhiana in our state. Then SPAD and green seeker really are to best technology, but still in the hands of the scientists, and there is a lot of effort need to be made. This is the outlook of the SPAD. It's like we can pinch the leaf of the crop where we need to apply the fertilizer. It provides us the chlorophyll content. So greater the chlorophyll content, it means we need not to apply the urea particularly to that crop. So it also uses the absorbance of the leaf in the red and near red areas. And the meter take about two observances like difference between the transmittance of the red and the infrared light, and generating a 3-digit SPAD value, which is proportional to the quality of the chlorophyll. As I explained, the chlorophyll, greater the chlorophyll content in the leaf, higher the reading. Then digital soil mapping. So digital soil mapping is also a burning topic. As in normal soil testing, what we have done, we have taken the soil samples and those samples tested in lab, but those reports are only for those points. But in the digital soil map, it also covers the area in between those 2 points where we don't sample the soil. So it's a very good technique. So digital soil map is a freely accessible and can to the land user like farmers, scientists, and policymakers. It helps to use the chemical fertilizers because we can estimate how much amount of the fertilizer is to be applied in the fields or in the areas where we don't sample the soil also. And this is the site, and we can easily better use these maps. So this is the digital soil maps prepared by my team for the Regional Research Station Kapurthala. This is particularly for the micronutrients. As far as pH is concerned, we can see that the pH is below 9.3. So the points having 8 readings above 8.5, there we need to apply the green manuring and all that. But as far as electric conductivity is concerned, all the point below having readings below 0.8. So there is no need to worry. But the points having readings above 0.8, 0.8, there is mean it is affected from the color soil. So we need to treat the soil even with the help of gypsum. We have to apply. Then the organic carbon, as we are in maps explained, this is the organic carbon. If the organic carbon is less than 0.4 on that sports, we need to apply 25% more urea than the recommended. Similarly, for the phosphorus, we have seen the points, red points having less than 5 kg per acre of the phosphorus. We need to apply the phosphorus over here. And in the region, if we have more than 55, there is no need to apply. Only the red region having less than 55 kg of the potash per acre, there is a need to apply the muriate of potash. Similarly, for the micronutrients, in the micronutrients for the iron, we have if we put sports having less than 4, in the zinc, sports having less than 0.6, and magnesium sports having less than 2, and the copper 0.2. So these are the sports, and there we can just by visualizing these are the sports indicating the sample where I have taken the soil sample, analyze them for the micronutrient. But in the DSM, we got the readings for the unsampled plots also, and we have a very handy information in that. This is the also some of the Ratikeda farm, our university farm, where we have tried to prepare the DSM, and we can have very good effect from it. And we recommend the fertilizers according to based on these DSMs. And really there is a reduction in the usage of the unnecessary fertilizers. This is the micronutrients. So micronutrients are very useful, and it helps in the proper efficiency of the macro also. So we need to check them also, and if there is any deficiency of these, we need to apply the micro fertilizers. Then coming on to the bed planting. So as far as bed planting operation is there, so in the bed planting zone, we have seen the water productivity highest over there, because in the bed plant crops as compared to zero conventional plot, we are receiving higher yields over there, and water usage is also less. But there is a problem. The fresh beds are quite effective, but as it aged, we need to reshape them. For reshaping them, we have to run the tractor. from the tractor, the side slopes of this bed compacted, and we have reported a higher bulk density and less root biomass over there. Here you can see that root mass density is reduced in the permanent bed as they aged as compared to the fresh beds. Here we can see that in the aged bed, we need to reshape them for the compaction of the side slope by the tractor tires is there. So there is a reduction in the root biomass and the bulk density is also increased. Yes, zero tillage is a quite popular technique, but my friends, zero tillage is only effective if the straw mulch is there. If zero tillage without straw mulch we are talking about, then I think it is the having lesser effect. It is more dangerous, I can say, than the conventional methods of tillage. So mulching is very much important. Why? Because mulching helps help the soil, and solar hot radiation will not contact the bare soil due to the mulch, and the vapor pressure gradients is higher, so it doesn't allow the vapors to come out to the soil. Wind velocity is reduced and is not allowed the vapors to move away the water vapor with it. So we have received very good response as far as straw mulch is concerned, particularly with the zero tillage. Here we can see that in the zero tillage, we have very good in our station. We have also sown the wheat with this operation. So major aim is to manage the crop residue of the leftover straw of the paddy, because mostly if the farmers has a narrow window, they are quite busy in sowing of the next wheat crop. But in that attempt, they generally earlier they used to burn these crop residue, and all you know, this is having many harmful effects on the human health, and there is a lot of hue and cry this year also. And this is some example that how this zero tillage helps to improve the grain yield, and how it helps to improve the irrigation water productivity, because the number of irrigation is reduced due to the less amount of the evaporations. Yes, here we can see that in the zero tillage plots, there is no need for the pre-sowing irrigation. And in an overall, we have reported with the 30% reduction in the water saving. 30% less water is required. So definitely we are reported here the higher water productivity. Yeah, now the date of transplanting, as I've already told, that you also earlier farmer used to go for the early transplanting, but this is the recommended date, 10th of June. We have calculated this based on the evaporation data, that there is a need to prolong the date of transplanting after 10th of June, because then rains are there in the July, and evaporation reduction. This is that effects shown that after 15th of June, there is no major effect on the grain yield, but the irrigation water requirement reduced and the water productivity also improved. So as a result of these studies, in 2008, an ordinance was passed and a law was made, the Punjab Preservation of Subsoil Water Act in 2009. Effective implementing this act helped to arrest the fall in the groundwater level. So here we can see that this is the percentage area transplanted in 1990, 1993, and 2008. But mass campaigns are carried out in 2005 that we must transplant the paddy in the field after the 10th of June. So with the lab, you can see that this after the 10th of June, the area is quite increased over here. That is transplanted after 15th of June. Now, as far as wheat transplanting is concerned, we have observed the October 25 to November 10th is the optimum time for sowing of the wheat. As far as irrigation, grain yield, crop water productivity, and irrigation water productivity is concerned. Yeah, this is our study published in Soil and Tillage Research, and here we also seen that the soil moisture content, particularly in the different mode of mulch, it helps to reduce evaporation losses. This is the diversification. As I already told that here we can also see in 1917 and 2008, the area under rice and wheat increased, but the area under pulses and grams is reduced. So there is a need to arrest this one. So you can see that earlier the water demand of the rice is just 1.18 million hectare meter, but in 2018 it increased 1.57 million hectare. Similarly, wheat earlier in 1970 we have 0.87 million hectare demand, then which increased 1.3 to 6. Finally, there are many technologies and many much to speak about, but coming on to the conclusion, yes, drone technology is a new one, but proved to be highly beneficial if more number of the demonstration is to be carried out in the farmer fields. And I think it is also on the cooperative basis, the farmer can benefit from it. And then leaf color chart, yes, it's a cost effective, just 100 rupees instrument, and the farmer can easily go for it. We also distribute it free of cost. And no doubt, SPAD and green seeker technologies are best, but still in the hands of the scientist. And I think it will take some more time to go to the farmer fields. And then laser leveling is there. Delaying transplanting up to the mid of June will significantly improve the. I already told you how it is used. Then short duration varieties, because shorter the duration a variety stay in the field, less number of the irrigation we have to apply. Then alternating drying, zero tillage, no doubt with the mulch helps to improve the water productivity. Digital soil fertility mapping is a new technology. Now I am posted in the extension system in the Krishi Gyan Kendra, and now we have prepared. We are also in the way to prepare the digital soil fertility maps of the Krishi Gyan Kendra, and we also then try to reduce the fertilizers by not cutting off the land productivity, which helps us to sustainable and judicious use of the these chemicals. Then the DSR, yes, DSR really a good technology, but we have to take about, we must identify the pockets where the soil texture is medium to heavy, and we must recommend this technology only to those farmers, because in the light texture soil, number of problems being faced by the farmers, it's not to work well. Then growing the wheat on the beds is here, it is also very good technology, and transplanting rice on the fresh bed, it saves. But as the bed aged, we are facing some problems regarding the bulk density, you can say, and root biomass is reduced. So we need to recreate the beds and again develop them. So these we have to get. Finally, a number of resource conservation technologies like direct seeding of rice, tensiometry is there, laser leveling there, bed planting, late sowing of that, late, not late, but timely after 15th June, and many more technologies are there. But we need to think over here that these are technologies cut off the drainage losses. So most of the resource control decrease the irrigation water amount by decreasing the deep drainage losses with a little effect on the ET, evapotranspiration, which is not desirable in the central district of Punjab, depend upon the underground water levels, but may be highly useful for the southwestern district of Punjab, which are really suffering from the problem of waterlogging, like Faridkot, Mansa, Bathinda, where canal irrigation is being applied. So real water saving when water flows, or flow of the water to the sink reduced from where it cannot be reused. Thus, finally, in and all, I want to share that resource conservation technology helps us to reduce the evapotranspiration losses, particularly two resource conservation technology, one delaying transplanting, and second one short duration of rice varieties. It really works wonder because it helps to reduce the evapotranspiration losses, not the drainage losses. Because there is also some argument that drainage, as more we reduce the drainage, then there are some impacts, adverse effects also. So then PA techniques like drones, SPAD, green seeker, laser leveling, they all will serve the purpose. Finally, I thanks to all. You listen very carefully, and thanks one and all. Thank you, sir. Thank you very much for listening carefully. Thank you. Hello.
अब यदि किसी का डाउट है तो आप चैट बॉक्स में लिख सकते हैं, है ना? रोहित जी, अब देखिए जरा किसी का
Sir, the things are clear. I have tried my best to convey the things. Even then, some doubts may remain over there.
ठीक है डॉक्टर साहब, तो क्या इसको कंक्लूड किया जाए सर? डॉक्टर साहब, एक दो डाउट्स हैं, जरा देख लीजिए चैट बॉक्स में आप.
मैं सर देख लेता हूँ सर, देख लेता हूँ.
जी जी.
सर मैं लिख के दे दूं, लिख के जवाब दे दूं, क्या ऐसे बोल दूं?
आप ऐसे ही बोल सकते हैं डायरेक्टली सर.
हाँ, तो जो डीएसएम की ये क्वेरी कर रहे हैं कि ये एरिया वहां से नहीं सैंपल कैसे हो जाता, तो इसमें क्या होता है कि सर हम जो कोऑर्डिनेट्स हैं लैटिट्यूड लॉन्गिट्यूड के हिसाब से हम जो हमारे पास जीपीएस रहते हैं उससे हम रीडिंग्स लेते हैं पॉइंट्स की, और आर्क जीएस सॉफ्टवेयर है उससे हम क्या करते हैं कि ये पहले आउटर बाउंड्री का मैप बनता है, उसके ऊपर फिर ये डिफरेंट रीडिंग को सुपर इम्पोज करते हैं, तो इससे जो अनसैंपल्ड एरिया है उसके भी ग्राफ बन के हमारे सामने आ जाते हैं जैसे मैंने दिखाई है। हिंदी में लेक्चर सर अगर आप पहले बोलते तो मैं हिंदी में ही कर देता। हिंदी इज आवर नेशनल लैंग्वेज, वी प्राउड टू बी हिंदी।
मोस्ट ऑफ द जो पार्टिसिपेंट्स हैं वो सब साउथ से हैं और इंग्लिश को प्रेफर करते हैं, कुछ पार्टिसिपेंट्स हिंदी को प्रेफर करते हैं, तो हम बाइलिंगुअल ही कर देते हैं, ठीक है, रिकॉर्डिंग हम प्रोवाइड
हाँ
कर
जी, हाँ
देंगे।
जी। नहीं सर, मैं भी हिंदी को बोलने को प्रेफर करता हूँ, हिंदी हमारी नेशनल लैंग्वेज है,
सर जो
लेकिन
साउथ
चलिए,
इंडियंस
लेकिन
हैं
क्योंकि
हमारे
सबके लिए
पार्टिसिपेंट
इंग्लिश अच्छा
वो
रहता
सफर
है।
कर जाएंगे, है ना।
ओके सर, काफी सवाल आ रहे हैं, इंग्लिश इज गुड, या इट्स ओके, इंग्लिश इज गुड फॉर द प्रोफेशनल्स, यस। Yeah, for the precision agriculture, we can start. It's not that area we required 100 acre or 50 acre. We can start the precision farming techniques even from the, I think, 1 acre. In mostly KVKs and the extension system, we go for the 4 canals demonstration plots. So we can demonstrate it at the area we want to have. So what are the methods of precision? Sir, already my lecture is on the precision agriculture techniques. So like leaf color charting, the drones are there, laser level are there. So precision agriculture is brought more precision in the agriculture techniques for improving the input use efficiencies. Yes, yes, precision agriculture is beneficial for the marginal and small farmers also. Thank you, sir. Thank you. Yes, sir. Data, yes, data. I can help you. You can note down my email ID. May I? Hello? Hello?
हाँ जी डॉक्टर साहब।
तो सर मैं अपना ईमेल आईडी डाल दूं, जैसे ये डॉक्टर साहब को, राव
हाँ
साहब को आंध्र
चैट
प्रदेश
बॉक्स
से
में
है कि
आप प्लीज
कैसे
चैट बॉक्स
मैपिंग
में अपनी
किया जाए,
ईमेल
वो
सेंड
बड़ा
कर
डिटेल
दीजिए।
में हो जाएगा।
जी जी चैट बॉक्स में आप ईमेल आईडी अपनी कर दीजिएगा सर, है ना, तो जो
क्योंकि
क्वेरीज
वो
होंगी
काफी
पार्टिसिपेंट्स आपसे डायरेक्टली ईमेल पे बात कर लेंगे, ठीक है।
हाँ जी सर।
ठीक है।
वैसे ये मेरे जो रिसर्च पेपर्स हैं रिगार्डिंग डिजिटल सॉइल मैपिंग आर आल्सो अवेलेबल ऑन द रिसर्च गेट, so you can write me email and I can explain you very carefully on that. Thank you.
ईमेल सर आपने पोस्ट कर दी है ना सर चैट बॉक्स में?
आज मैंने ईमेल लिख दिया सर।
जी आई थिंक वी कैन कंक्लूड सर, है ना।
ओके सर, ओके।
ठीक है, थैंक यू सो मच सर, आपने अपना समय दिया और मेरे निवेदन पे आपने इसको स्वीकार किया, बहुत बहुत धन्यवाद सर। आगे भी यही।
थैंक यू वेरी मच।
ठीक है, हम मीटिंग लेफ्ट कर सकते हैं।
ओके सर, थैंक
किसी को कोई डाउट है आप डायरेक्ट ईमेल कर सकते हैं स्पीकर को, जो हमारे स्पीकर हैं इन्होंने ईमेल आईडी अपनी दी है, आप डायरेक्टली ईमेल कर सकते हैं उनको, ठीक है।
यू। यस,
ठीक है, थैंक यू।
once again I want to thanks all of you sir, thank you।
रोहित जी कंक्लूड करिए।